Hey, fellow mathematicians! Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or rote memorizing facts, but it's about thinking and reasoning, about creating and using mental relationships. That math class could be less like it has been for so many of us, and more like mathematicians working together to learn more math. We take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what?
Today we're going to be wrapping up the series we've been talking about for a few weeks now, models and modeling.
Very important. We hope we have clearly made the point that for us, modeling is not about CRA, concrete representational abstract or concrete pictorial abstract, that sort of series of using models and modeling in math. That is not what we do, because that all too often is just a way to get kids to do the algorithms. Not our goal. Our goal for math is much more about giving students problems, helping them make sense of them, pulling out how students are reasoning, representing that thinking, using important models, making that thinking visible. Then, over time and with lots of experience, those models become tools for thinking. That's how we think about modeling.
And that there are particular models that we think are useful for students. The open number line, the open array, and the ratio table are some of the most important and most useful. Today, we're going to address a few common models that people really love, and we'd like to push back on exactly what they are and are not useful for.
Yeah, so let's get a little controversial today, Kim.
Okay.
Let's talk about a few things that we hear lots of teachers talk about and use. We see them all the time in classrooms.
Mhm.
And like you said, let's get a little clarity around what exactly they're useful for and maybe not so useful for.
Yeah.
So let's just list them out right off the bat.
Okay.
Hundreds charts,
Mhm.
base 10 blocks, base 10 materials,
Yep.
and algebra tiles.
Some really popular ones, right?
Really popular. We see them a lot. Of course, depending on the grade levels, you might see different ones. They have some things in common, which is why we're talking about all three of them today at the same time. But let's get really clear, just for listeners, that we have lots of grade levels listening. So,
Yep.
Kim, will you describe briefly hundreds charts? What
Sure.
is a hundreds chart?
Okay, yeah. So a hundreds chart is a chart that goes from 1 to 100.
Well, it
And
could be 0 to
could be 0 to
99.
9.
Yeah,
Yeah, that's
yep.
why I said that. I was picturing it. So 1 to 100, and it's arranged in a 10 by 10 grid. So on the first row would be 1 to 10, and then the next row would be 11 to 20, continuing on until the last row is 91 to 100.
And there's some pretty cool patterns that you can see in
Yeah,
hundreds
absolutely.
chart. In fact, I remember briefly meaning Pam, be brief. That's me. That's me telling myself to be brief about this story. When I was working with my kid's second grade teacher, I would often go to my kids' teachers at the beginning of the school year, and I would say, "Hey, I'll help. Give me anything. I'll make copies. I'll laminate. I'll do whatever you need me to do for the first few days, and then after that, can I do some math with you and your
Sure.
students?" And so one of the things she said to me was, "Oh yeah, will you put the hundreds chart back together?" So she had a pocket chart and cards with
Mhm.
those digits in it. And she said, if you'll just put these, all the cards were out and the pocket chart was empty. And she's like, we just put them where they belong. And I looked at the first card and it was 54. And I thought to myself, where does this go? Like, this is
Uh-huh.
a high school math teacher looking at this hundreds chart. And to me, that was like a really cool thing for
Yep.
me to have to figure out where 54 went. And kind of like you just said, it could be 0 to 99 or it could be 1 to 100. And I needed to know that before I could put 54 on that
Yep.
chart. I needed to know, what was her what was her range, the set of numbers that she was going to put. Anyway, so all that's cool.
Yep.
There's some really cool things we could do with hundreds charts, and there are less cool things we can do with hundreds charts. Let's keep going.
Okay.
Kim, what are base 10 blocks or base 10 materials?
Oh, base 10. Okay, so you're going to have a little tiny cube that's going to represent 1. And then 10 of those little tiny cubes attached together makes what people would call a rod. So it represents 10. And then 10 of those rods attached together make what somebody would call a flat. It's the most common name, I think, flat. And that would represent 100. So you have 1, 10, 100. And then 10 flats put together make a larger cube, which represents 1,000.
Because I've got 10 of those flats,
Mm-hmm.
or hundreds, and 10 hundreds is another
1,000.
name
Yeah.
for 1,000.
Yeah.
And so it nicely represents sort of place value, right?
Mm-hmm.
Because we've got sort of 1 1 and then 110 and then
Yep.
100, and then put those together and we get 1,000. And so there's, hey, look at all that place value that is embodied in those Oh, let's see. We talked about that in the last episode. So
Mm-hmm.
so if that's a little unclear to you, when I'm trying to like jest a little bit here, is that we sometimes think that because we've made sense of manipulatives and we've put those values in there, that it naturally just occurs to kids. It
Mm-hmm.
just is all of a sudden clear. Oh, it's so clear, the place value in our number system,
Mm-hmm.
or not.
Right.
And it can really get obscured when then we don't even call them 1, 10, 100,
Right.
1,000, and we
Right.
call them, I don't, what do they call the one? I don't even know. Is there
Unit
unit?
usually. Yeah.
So unit, and then rod. Is that right?
Uh-huh.
Rod,
Rod.
and then
Or
flat.
stick. Stick is another. Rod or
Stick.
stick.
Nice. Yeah. So you might be interested to know that when I was, again, same sort of year, I was working with my kid's teacher, and after I did the first week, and so later I'm like, hey, can I do some math? One of the things I did was pull out some kids and like enrich them. I would just like, give me some
Mm-hmm.
kids and I'll do some things, which really meant that I sort of played around with math with them. So I tried to figure out what younger kids were doing with math, because I was a high school math teacher and I was just starting to dip my toes into what it meant to do younger math, like really think about how kids were thinking. Anyway, so I'm in the midst of that one day. They said, hey, we're not going to let you have a group of kids. We're just going to give you this one student. She's really struggling with addition. And so here, go teach her how to add with these base 10 stuff. I mean, they just really handed me like this bin of things. They're
Yeah.
like, go teach her to
Tub.
add. And I was like, what are these? I as a high school math teacher, I hadn't really ever seen them. And I looked at them and I was like, oh, okay. Well, like, and I could kind of see the place value that was, so I had a lot of relationships already built in me. So therefore I could kind of see some things happening in the manipulatives. And so I sat down with her and I said, hey, tell me about these. And she goes, well, that's and I honestly don't remember what she called the one. Maybe, I don't know. Yeah, I don't remember. But then she said, that's a rod
Mm-hmm.
and that's a flat. And I said, okay, so like 42, like make 42 for me. And she's like, looked at me and I said, well, like what do, grab a 10. She goes, there aren't any tens. I'm like,
Mm.
what? Okay, a rod, but what does a rod mean? She goes, it's a rod. And I
Mm-hmm.
was like, yeah, but like it's 10, right? She goes, it's a rod. And
Wow.
bless her
Yeah.
heart. I mean, that in that moment, I was like, oh, like you really think this is a rod, not a
Yeah.
10. Like it didn't mean 10 to her. Now, maybe we could talk about how it could mean 10 and everything, but it was one of those moments where I was so clear that what was supposed to be clear to someone by looking at the manipulatives or even messing with them was not clear to a student who hadn't already constructed some ideas about what 10 meant, that
Yeah.
110 is also 10 ones. And this young student, who I think was in first or second grade, had not constructed that. And so it was a rod. And I was like, well, how many do you have in your hand? As she's holding on to that rod, that 10, how many do you have in here? She looks at me, one. I'm like, you have one rod. Yeah, I've got one rod. Well, how many does this represent? The flat one.
Mm-hmm.
And so anyway, it was just an interesting moment for me to go, oh, there's more to this than we can't just hand these manipulatives to kids
Yeah.
and think that the math is going to be apparent.
And let me add in that I
Yeah.
don't think that just calling it 1, 10, 100,000 instead of unit, rods, whatever, stick, that's not going to fix the problem that kids don't make
Mm,
sense of what it is, right? So if that teacher maybe called it those names, calling it mathematical names isn't going to fix the fact that the math is not embodied for them.
that's not magical. That's
Yeah,
not the
yeah,
magical
it's not
fix.
just they named it wrong.
Yeah, it's a really good point, because you could have heard me mean that. Yeah, thanks for
Yeah.
clarifying. Yeah. Okay, so let's talk about that third model. So algebra tiles.
Yep.
Algebra tiles we typically use once we have kids messing around symbolically with x's and variables, and we want kids to kind of have some sense of what they mean. And so, typical thing that we might do with algebra tiles. Oh, I'm supposed to describe them. So don't do yet, Pam. Describe. So I might have a rectangle. It's kind of usually a rounded rectangle that we call an X, and then I have a square that's the same height as the rectangle, but not as big of a width. To me, it looks like it's, I don't know, about a fifth or a sixth of the rectangle that represents X, and that's a unit. So we've got sort of a block that represents, they're flat, so they're not real. I mean, they are 3D, but they look more 2D-ish. So this flat rectangle sort of represents X, and then we have a smaller square that represents a unit. And then if we take that X and we make it X by X, we make a square out of that X, then that's X squared. So they're actually sort of similar to base 10 blocks in that we kind of have these physical squares and rectangles that are representing kind of unknowns. And so like a 1 by 1 is that unit, and then a 1 by X is that rectangle that represents X, and then an X by X is the rectangle that represents X squared. And then similar to two color counters, there are two sides, and one color represents positive ones, X's and X squareds, and the other color represents negative of the opposite of those. And so we kind of have positive sides. And what are you laughing about?
I'm laughing because thank goodness for Google, because if people can't make sense of what you're saying, you can just look up what an algebra tile looks like, right?
There you go. That would probably be wise. One of those things. Don't listen to the podcast while driving. Maybe listen to the podcast while Googling what do hundreds charts, base 10 blocks, and algebra tiles look like. Okay. Yeah. So what's kind of funny for me, Kim, is that you're laughing as I'm trying to describe algebra tiles to like maybe elementary teachers, but I'm laughing a little bit while you're describing 100 charts of base 10 blocks to high school teachers. Right. It's all good. Okay. So if that's what the materials are, let's talk about maybe some limitations to those manipulatives.
Okay.
So in the last episode, we talked about 3 limitations to 10 frames, and I'm going to mention those same 3 limitations, and we're going to apply them to these manipulatives. Okay, so the 3 limitations: procedural. Is the thing that you're doing really more about procedures and steps? That's number 1. Number 2, do you find yourself reading off the answer, almost like, surprise, what's the answer at the end? That should be a ping that you're doing less mathematizing and more mimicking. And 3, is there a bunch of one-to-one, one-by-one counting? Remember the development of mathematical reasoning, counting is this less sophisticated thing. And so if we're supposed to be building additive reasoning or multiplicative reasoning or proportional reasoning or functional reasoning, I don't want to demand that in the midst of that, kids have to count, that they can solve the problems getting away with less sophisticated thinking when I'm trying to build the more sophisticated thinking.
Right.
Okay, so those 3 things. Kim, if I were to give you a problem like 48 plus 54,
okay,
and what are some ways that we're using hundreds charts to solve 48 plus 54, and let's pick out those 3 things.
Okay, so 48 and 54. I mean, I could start with either number, right? But I'm just going to start with 48 because it's the first one.
Okay.
48. So plus 54. I'm going to find the marker on 48. I might put my finger on it, put a cube on it, start at 48. And then I might move forward 4. And I would count 1, 2, 3, 4. And I might have to, I'm going to have to roll over to the next row. And then
because you're doing this on that chart,
right?
That chart of 100
you're
numbers.
Your finger, or your manipulative, whatever, your counter, or your cube. And then to move 50, I'm going to go down a row 5 times. Down 10, down 10, down 10, down 10, down 10. Except, you just gave me 48 and 54. But on a hundreds chart, it's called 100. And so 48 and 54, I'm not going to actually find on a hundreds chart, right? You could also start at 48 and go.
Well, maybe slow down a little bit, because if anybody's not doing the math. So 48, maybe just go by the tens. 48,
okay,
58.
Well, that's what I was going to do. 48 plus 54. So I might say 48 plus 50, and I'm going to go down 5 rows, down 5 tens. And that would put me at 98. 48 plus 50 is 98. And then I'm going to go over 1, 2 to get to 100, but then I'm off the chart at that point because 102.
There is no answer.
Right. It's, or I mean, theoretically you could have a 200s chart, which then is a whole other thing.
Or you could stack a hundreds chart on top of a hundreds chart, or next to, or whatever.
It's possible. Okay. So anyway, the only options you have are to move by ones or move by tens one at a time.
Yeah. So procedural, we see kids often they go to the first number. And like you just said, I'll just go to the first number. They don't even think necessarily about starting with the higher number so that they can then add less on.
Right.
And then they either, like you said, add the ones and then kind of go down by rows for the tens or reverse it. And so that feels very procedural.
Sure.
This is our number one. That's procedural.
Right.
And then when they get to that 102,
ta-da!
It's almost like, ta-da, like, and when you said you're moving your finger or you're moving a marker or something, they sort of move their finger, move their marker, and then they almost have to look underneath it, right? They almost have to, they've put their finger on it to get there, and then they have to like, what is under there? I don't know, because I just did the thing. I did the procedure, and now it's like, whoa, where am I?
Yeah.
They're reading off the answer. So that's our number 2 thing that should
you know why?
us. Oh, yeah, keep going.
You know why? Because really, once you start at the 48, the only thing you're considering is I got to move 54, right? I have to move 54. And as long as I've moved 54, I don't have to consider where I've landed. I don't have to consider anything else because I'm only going to move by tens or ones.
And you also didn't have to consider really where you started. Like the relation, what 48 is close to what, or 48 plus 50. Do I know that like you're just doing every time adding ones first and then tens, or adding tens first and then ones, procedural.
Yep.
Yeah. And so you're not considering what kinds of jumps you're making, or like you said, where you're landing. I just repeated what you said. Sorry.
It's okay.
So, sometimes I repeat what you said, listeners, just so you know, because I'm making sense of what Kim is saying, and that's me making sense of it out loud. So it's not me saying Kim didn't make sense. It's just the fact
sometimes I don't. It's okay.
It's just that I'm slow. It's all about me being slow. And I'm okay with that. I'm okay with the fact that I'm slow when I do real math because I'm doing real math. Yeah. And I would prefer to do real math slowly than fake math quickly.
Yep.
Okay. So let's see. So we got the fact that it's procedural. We got the fact that we're reading off the answer. And then noteworthily, in order to add those 4, we had to count by ones, right? And in order to add the 5 tens, you had to count by 10 one at a time.
Yep.
So all this one by one counting, those are our 3. It hits all 3 of our markers. Bam! That we don't love that for hundreds charts. Okay, cool. So we're not a big fan of using hundreds charts for computing. Similarly, let's do the same kind of thing for base 10 blocks. Okay. So me or you, who's going to describe this problem?
I will.
Okay.
So base 10 blocks, right? If we just talked about what they look like. So if I'm adding, let's do the same problem, 48 and 54. So what I would be doing in that case is I would grab, hopefully not 48 cubes. I would grab 4 rods to represent my 40, and I would grab 8 units to represent the 8, and I've built 48 on my desk or wherever. And then I would grab 54, so that would look like 5 rods and 4 units. And I would lay them all out, and then it's time to add. So at that point, I would collect my 8 units and my 4 units, and I would exchange those because I have 12 units, and I would exchange those because somebody told me that I can't have 12 units. So I would take 10 of my units and exchange that for the next rod. And then I would have 4 rods and now 6 rods. And then I would take those 10 rods and then exchange them again for a flat. So I would be left with a flat and 2 units. And then I'd look at what I have on my desk and I would say 102.
And you sort of read off the answer. So bam, instantly right there, we can sort of say, I've done this tradey thing. I've collected. Well, first you built.
Yep.
And as you were building, I'll just mention, you had to count one by one in order to build. Even if somebody's listening right now and they're like, but I would draw them on paper. Even if you were drawing them on paper, you had to count one by one to create those 8 and to create those 4, or to create the 4 tens and to create the 5. You counted one by one to do that. So lots of counting. When we want kids thinking about 48 and 54. We don't want them thinking about like counting 1, 2, 3, 4. That should have been done before. If we're adding 48 and 54, we're beyond that, and we want to be thinking about the numbers themselves. So counting one by one, we hit that. Reading off the answer, we just hit that, sort of like, there they are. And it's like, oh, hey, what did we end up with? And then you sort of read that off. And then does that feel procedural?
Yeah, absolutely.
Quick story. I was in a classroom, and all of a sudden I would hear this smack. And I was like, what is happening? The entire class was smacking their hand on their desks. And then the teacher would say something and smack. And I was like, I'm intrigued. What's happening? And she would literally go, okay, everybody, take all of your units and count 10 of them out. And ready, everybody, trade. And when she would say trade, everybody in the room would smack their hand on the desk, and they would take those 10 units and they would put out that 10, or that rod that you're calling it. Or they would take the 10 rods, the 10 tens, and they would, okay, everybody ready? You got 10 tens, everybody, and trade. And when she said trade, they'd smack their hands on the desk and they would trade. It was, to me, that like smacks of procedural. It's these are steps. This is what we're going to do. Can I just mention that when you were gathering all of those units and then you're like, okay, I've got 10 of them, so I'm going to trade that for a rod or for a 10. I was like in my head going, whoa, why are you gathering the units first? Like I would have looked at the bigger numbers. I've been doing real math long enough that my gut instinct was to think about the 40 and the 50 first, not the 8 and the 4 and then trade up. And I get it. I know why you're doing that, because when you trade up, then you don't have to, oh god, how do you describe that? If you go from small to big, then it just sort of trades nicely. If you go from big to small, then you have to kind of trade as a second thought, right?
Yeah.
Like it's like
There's
you
a
add
lot
the
of
40.
trading.
Yeah, there's more trading because you
Yeah.
sort of add the 40 and the 50 together. And if I had to trade there, I would, which I don't for that problem. But if I would, then when I go over to the units, then if I get another 10, then I might have to rebat. Anyway, so yeah, so I get why you're doing it, because if you're doing the procedure, then you would of course do it from small to big. But research is clear that if kids are thinking about numbers and we have not superimposed the algorithm, kids will think about the big numbers first. So
Sure.
here, there's an extra thing that is going wrong with base 10 materials, is we're working against kids' intuition by working with the small numbers first.
All right. Let's talk about algebra tiles.
Okay. So algebra tiles. Typical thing that we might do with algebra tiles is something like x plus 3 times the quantity x minus 2. And so if I've got these two linear binomials and I'm multiplying them together, x plus 3 times x minus 2, then I might think about that. Oh, see, now I'm trying to put all this meaning into it, not be real procedural with it. What we see kids do is they'll put that x, that rectangle that represents the x, and then 3 units kind of down the side. So vertically, I've got a rectangle and then a unit, and that's sort of forming a vertical line. And then next to that, going horizontally, I would put an X, and then I would put two units, but flipped over. So they're negative.
Right.
So 2 units, but they're negative, because now that's x plus 3 by x minus 2. And I'm sort of creating a rectangle where we're going to look at the area. I had to put some meaning just to help you sort of like visualize it. Like that's the visual. And then I'm going to fill in the area of that rectangle. I have 2 dimensions, x plus 3 on one dimension, x minus 2 on the other dimension. And I'm going to fill in the area of that rectangle that's missing. And so then kids would, where I have the x by x, they would put an x squared, and that x squared is a big square. So it fills that whole area of x by x. And then where I had the 3 units, now I have a 1 unit, 1 unit, 1 unit. Well, a 1 unit by an x is x. So now I would put a horizontal x, another horizontal x, another horizontal x. Now I'm over on the other side where I'm thinking about those 2 units by x. So I would have 2 vertical x's. And now I've got just this space in the sort of right-hand lower corner that's empty. I need to fill it in. Well, that's going to be 3 units by 2 units. And so I'd fill that in with 6 units. And it's funny, if you could see my hands, I'm literally like 1, 2, 3, 4, 5, 6. Like I'm da, 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 which should scream at you, I'm counting by ones. Like all of those counting by ones that I was doing, when really we want kids thinking algebraically, not counting, all that counting. So counting by ones, that's happening. After I've put all of those manipulatives down there, those cubes or rectangles, I guess they're all rectangles. After I put all those rectangles down there, all those, what's the word I'm looking for? Blocks? They're not blocks. They're tiles.
Pieces?
They're called algebra tiles. How about tiles? That's a thing. After I put all those tiles down there, and then I have to look at them and I have to go, okay, I've got an x squared. I've got a bunch of x's. How many x's do I have? Look, I have to count them to see how many x's I have. And then I have a bunch of units. How many units did I end up with? Oh, I count those and how many units I ended up with. And then I can say, okay, I've got x squared plus I've got 5 x's. I didn't actually do this problem. I've got 5 x's, and then I've got 6 units, but they're all flipped over. So -6. I've got plus -6 or -6. So again, I'm sort of reading off the answer. I've done the work. I've done the procedure. So of our 3 things, I've done the procedure. I've done what you told me to do. I put the ones on the left. I put the ones on the right. I filled in all the stuff in the middle. And then I've read off the answer. That I've done the procedure. I've read off the answer, and I was counting one by one. All 3 of our things that we don't love, I'm sort of, doing with Algebra Tiles. Not my fave.
Which people love, right? This is kind of what we're talking about. All 3 of these manipulatives is because they are so popular.
Yeah. So let me just mention, we're running out of time. We're really going long today. Thanks everybody for paying for listening to this one. We actually like using these 3 models, but only to build relationships, not for what we just did. So what Kim and I just did with these 3 models was compute. We use them for computing, and that's when we have those 3 problems. So in a later episode, we will talk more about models for building relationships versus models for computing, for doing the math. And those are different. One is a subset of the other, and we want to be careful about not using some models to compute when we get those 3 things that we don't want, where they're counting one by one, where it's all about procedure, and when you're reading off the answer. And let me just mention one last thing about why we don't like these 3 particular models for computing, because kids get stuck in them.
Oh, yeah.
We have literally seen kids on some sort of assessment where they're supposed to add numbers together, redraw a hundreds chart in order to use it to add. That is not ideal, and we don't want it. All right, so models and modeling in mathematics. Who knew there was all this stuff to talk about? We hope we've given you some things to think about and consider. When in doubt, remember the development of mathematical reasoning and ask yourself, does this model help move students forward to more complex thought, or might it inadvertently be trapping them in less sophisticated thought? Do you see a lot of one-to-one counting that's necessary, they have to do, when students should be building more sophisticated thinking rather than just counting? Does it feel like it's more about imposing someone else's thinking? Or does that model lend itself to representing the student's own thinking? Does that model have the potential to be a tool for working out the relationships, a tool for computing with the relationships? When using that model, do you tend to read off the answer at the end, or were you cognitively involved in deciding how to use relationships? So Kim, how would you wrap up this? Anything else to add?
I'm going to be succinct. In short, does the model that you're choosing help kids mimic, or does it help them mathematize?
Bam! Oh, that's brilliant. All right, that's the big question to ask as you look at models and modeling and manipulatives in your class. So, if you want to learn more mathematics and refine your math teaching so that you and students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable.